Hi, thank you for attending. It's great to have you with us. My name's Gordon. During this period when our training centres are closed, due to the government's COVID-19 guidance, we were providing live training sessions on various topics to help you continue with your progress with your course. We're all centre assessors, and during difficult times, you'll be getting us beamed directly into your home. Please remember to take notes throughout. It's really important you take notes because during a session, we're going to have some questions which you'll need to answer. So please stick with it and keep those notes flowing. During these difficult times, there's a very high usage of the internet. So if I cut out from time to time, don't worry. It just means the internet's very busy worldwide. But even if the picture's a little bit laggy, you'll probably still be able to hear me. So bear with us. Hopefully it won't cause you too many problems. During the lesson, I'll be playing some videos. If you have a pop-up blocker or an ad blocker on your machine, then the video might not play correctly. If the video doesn't play, you'll need to refer to the recording of this session, which will be available at some point next week. One final point, when you log in, it would really help us if you could just use your first name and your student number. So John WF 12345. Okay, fantastic. Right, today's session is all about safe isolation. Now, safe isolation for most of you is probably a term you've never heard of, but it's a very, very important term in the electrical industry. Every time you test or inspect a circuit, whether that's one you've put in or one you're checking on behalf of somebody else, or you're going to do a check on somebody's house where they've got problems, the first thing you must do is safely isolate the circuit you're working on. It sounds obvious, but so many people don't do it, and consequently, so many people get injured because there's still electricity flowing in that circuit. So today we're going to go through the sequence of showing you how to safely isolate a circuit for a single phase board. Now, for a three-phase board, it's exactly the same, but there's a few more stages. Why this is important to you also for your course, at level 2, on week 4, you'll be doing what we call a 204 practical assessment. You'll be building quite a few circuits of different materials, a lighting circuit, a power circuit, and a socket circuit. Now, part of that installation, at the end of it, you need to test it. Before you can test, I've just mentioned, you always must safely isolate it. In addition to that, you've got 2 testing exams for level 2 and level 3. You've got your 2391 and your 2392. A big part of that exam assessment is about safe isolation. Now, the assessors, it'll be on a one-to-one basis. If you don't safely isolate your circuit, the assessment will be terminated instantly because you're putting yourself at risk of getting electrocuted. Okay, so safe isolation is vital. You need to know how to do it. So we're going to start off with a little PowerPoint showing the steps. Then I've got a video to show you, which will go into a little bit more detail. And then we've got the questions. Okay, so it's your turn to be assessed. So if we first of all turn on the PowerPoint. Make this bigger. And we can see, here we go. So you're obviously all aware electricity has its dangers. You can get electric shock. It can cause fires if there's faulty circuits. You can get a burn from it. And equally, in some instances, you can explosions from electricity. As I've mentioned, testing is vital. You always need to test the circuit. Even if you've put the circuit in and you think all the cables are nice and in the correct order and they're nicely terminated, you never know somebody else for instance, if you're rewiring a house, generally speaking, when you're rewiring it, the householder might have somebody else in. They might have a kitchen being fitted. You don't know, after you've put your cables in, one of the kitchen fitters might have put a screw right through your cable. A plumber might have accidentally chopped your cable when he's putting his pipes in. So you're not 100% sure just because you've put it in, but those cables, when it comes to turn on time, are still good and correct. Okay, that's why we must test. But before we test, we always must inspect. An inspection is literally just looking at what you've put in. Then we have a series of dead tests. Dead test means we test the circuits when there's no power. And then live tests means we test after we turn on the power. So for safe isolation, you need to have some equipment. All your equipment has to conform with guidance HSE GS38. Now, for most of the kit, it's pretty much all the same. And a couple of ones what I'm going to go through just now is just on leads, nice and simple leads like this. If you look at the end of this lead, there's a small exposed tip. GS38 says that can be no more than 4 millimeter. The reason for that is obviously the bigger it is, the more you can touch when that's touching the live component. It's got to have a finger guard. So again, when I'm using it, my fingers can't slide onto that tip. And equally, and I think this is for me the most important one, inside this barrel here of the test lead, there's a fuse. So if in the obviously extreme circumstances, this blows up, it's better this blows up because this is, I don't know, £5 compared to your test equipment, which could be up to £1,000 blowing up. So there are 3 things every single lead must have. So the sequence of safe isolation, the most important thing to start with, ask permission. Before you turn off any power supply, you must ask permission, whether that's a householder and you're just doing some repairs on a light, or indeed you're working in a bank. You can imagine the scenario, you walk into a bank and the service manager or a repair guy says, yeah, turn off the power, it's not a problem, you can start working. So you go and flick the circuit breaker and all the power sockets to the trading floor go dead. You can imagine that could go into millions or billions of pounds worth of losses, and you'd be responsible for it. So when you're working on a commercial industrial scenario such as that, you must always get what's called a permit to work. It's a piece of paper allowing you to actually do work. So if anything does go wrong, it's not your fault. Same with a house. Just because somebody has said turn the power off, just make sure there's nobody else in the house using electricity. They might be working in a home office upstairs, for instance. Just make sure they all know you're going to turn the power off, so it gives them time to download or save any work they're working on. Once you've turned the power off, or got permission to turn the power off, you then put warning signs up. And again, this will vary depending where you are. If it's in a large installation, you can have more prominent signs. Obviously, if you're in somebody's house, you probably wouldn't have too many signs around. So we've got a flow chart here on the procedure for safe isolation. So as I said, first of all, check where it's convenient and safe to turn the power off. We'll identify the circuit to be worked on. So that's probably a circuit breaker for the upstairs lighting, for argument's sake. We then identify the means of isolation. And if we concentrate on a single phase board in a domestic property, such as in your house, that'll be the main isolator for the consumer unit. We then check the source of supply, the incoming supply, so the main live and neutral from the meter. We check that with a voltage indicator, make sure it's there, and then we isolate it. And when we isolate it, we put a padlock on, we put a notice to say electrician working, we then lock it off and we put that key in our pocket. It's very important we put that key in your pocket, and you'll see this on the video I'm about to show you. You never leave the key anywhere other than your pocket, because somebody else could come along when you're, let's say they're consuming it's in a garage, you go upstairs, the key's there, somebody else could come along and inadvertently take the key, open the padlock and put the power on when you've got live sockets in your hand. Very, very dangerous. You don't want to do that. Once you've isolated the circuit, you then test it with a voltage indicator. But before you do that, you put the voltage indicator on what we call a proving unit, which is basically a box of batteries, just to make sure the proving unit and the voltage indicator is working. Test the circuit and then reprove it. Okay, then it's safe to begin. Now that sounds like a really long-winded way of doing things. It's not really. It literally takes a couple of minutes to actually do it. And the most important thing, those couple of minutes could actually save your life, because you now know that circuit is dead and safe to work on. So safe isolation procedure, always use safety lockouts to make sure it's all safe so nobody else can turn it on, and do never ever work on a circuit live. The electricity work regulations state you must never work on live cables unless, and this is the key thing, it's vital, you cannot turn it off. So in other words, for argument's sake, when you see guys working on the roads and they're repairing cables, they have to keep it live. Okay. I don't think there's any circumstances in a normal electrician where you have to work on anything live. It should always be dead. And if your boss insists you work on it live, maybe he's not probably the right boss you should be working for, because he's putting your life at risk. Okay, so always turn power off and always isolate it. So as we've said before, electrical testing, you'll see you'll get what we call the on-site guide, which is a small booklet which talks you through how to test. And like I said, testing is separate to inspecting. Inspection is basically just checking, you're dropping a few sockets, dropping a light down, making sure the cable's the right size, the right colors, they're terminated correctly. Compared to testing is actually where you're using a multifunctional tester to make sure that everything's electrically correct according to the regulations. So we've got two types of tests, as I've mentioned. The ones in green are dead tests, and the ones in red are live tests. We'll be doing further sessions on these tests a little bit later on, so you'll get a lot more knowledge. And like I said, when you come into the centres, you'll be doing lots and lots and lots of testing, because you've got specific exams on them, and it's something which separates a good electrician from a bad electrician if you know how to test. It really does. And you actually get more money in industry if you can test, and if you've got the qualifications, the 2391 and the 2392, which you'll get with us over the next couple of years, you'll actually get more money as an electrically qualified tester, as opposed to just being a regular electrician. So, as I've mentioned, I'm going to put on a video to show you safe isolation in action, and then we're going to have some questions. There's 10 questions. Just to emphasize again how dangerous it can be, last year there were 26 deaths directly through electrocution. There was 15,000 fires attributed to bad wiring in this country. And there were 1.2 million electrical accidents where people have just got electric shocks or burns. Okay. I'm not saying all of those would have been not happened if we had been safe isolation, but a lot of them could have been prevented if the correct procedures had been taken. So let's have a look at this video. Don't forget to take notes, as I've mentioned. Here we go. Enjoy, but take notes.
In this presentation, we're going to do the safe isolation procedure so we can isolate the consumer unit, and in this case we're simulating a domestic dwelling, in order that we can work inside that consumer unit, perhaps to add an extra circuit or carry out some of the tests safely without the supply being present within the consumer unit itself. We're fortunate in this case we have a linked main switch in the double insulated meter towers, remote from the consumer unit itself. So we're going to perform isolation here. So we're going to turn off that double pole switch and prove the consumer unit itself is isolated and therefore safe to work on it. Once we have turned off the linked main switch in the towers, we will need to put on a locking device and a sign so people are aware that the supply has been isolated. Let's see how we're going to do that. So as stated in previous presentations, I never like to turn off switches on full load. However, to give me some sort of indication that the isolating switch has turned off the installation, I might want to leave one or two circuits on. Maybe I want to leave a lighting circuit on, or in this case I've plugged a voltage indicator into one of the socket outlets. Therefore, when I do operate the linked main switch, I have some visual clues that the supply has actually gone off before taking the consumer unit cover off and actually proving it's dead. So in the installation, we're going to first of all limit the amount of current that the switch remote from the consumer unit will turn off, and I'm going to turn off circuit breaker, circuit breaker, circuit breaker and circuit breaker, leaving on one of the circuit breakers here that supplies the socket outlets. We can see my plug-in voltage indicator is still illuminated, but we're not going to be turning off the whole of that installation on full load, and we have a visual clue when we return to the installation the supply has gone off before the cover goes off. Equally, you could leave a lighting circuit on as well. So I'll go to my linked main switch remote from the consumer unit itself, and I'm going to turn that off. This could be located away from the distribution board, and therefore you mustn't leave it at any stage turned off and re-enter the building to see if, for instance, the voltage indicator has gone off or lights that you've left on. Regardless whether you turn off the right switch, and it could be that there's several of these linked main switch feeding several flats in a building, you will still need to secure isolation with a device and a lock and a sign before leaving it to see if the installation has gone dead. Ours is adjacent to the consumer unit. We will be able to see if the plug-in voltage indicator has gone off when we turn it off, but the process is still the same in the real world. You must lock it off and put a sign on it before leaving it. So we go to the linked main switch in the tails now, and we turn it off. If this is remote from the consumer's unit, we won't know what's happened to the plug-in voltage indicator down here, but we have got to secure the isolation at this stage. So we'll do that next. So I need to secure the isolation. I take the device, I position it onto my linked main switch or double pole switch. I'm going to tighten down the clamp on this style. They're all slightly different. And then we're going to tighten that onto the actual linked main switch itself. Might need to take a pair of pliers just to make sure we nip that nice and tight. Okay, and that device now will not come off. We position the locking device over, and you can see already you cannot turn back on that switch, but it still needs to be secured with a padlock. Padlock is accompanied by a sign suggesting what we're doing, like so, but I prefer the master lock, so we can do it that way. Equally, we can insert a master lock. The beauty of this is if there are several trades on site, plasterers, plumbers, painting decorators, that would be affected by re-energisation of supply, everybody has a chance to insert their own padlock. So the electricians put his padlock on, plumbers, painters, carpenters, etc. can also add their padlocks on. Therefore, the supply will not be able to be returned until everybody's agreed it's safe to do so and remove their padlock. So we've locked it off at the linked main switch remote from the consumer's unit. We now need to go into the consumer's unit in order to prove that it has been isolated. So I've left the linked mains switch isolated and secured. I've taken the keys with me and I've come to the consumer unit. Before removing the consumer unit cover and proving the circuit is dead, we're going to need to check our voltage indicator on a proving unit, as we did in previous presentations, before we use it. So let's do that next.
Remember, he took the keys with him. He didn't leave them lying around.
So let's do that next.
So before using my approved voltage indicator to prove that the consumer unit has been isolated, I need to check it first of all on a proving unit or a known supply. The easiest thing to use is a proving unit. As I probe into my proving unit, you should see the lamps illuminate on it, suggesting it is working correctly, like so. Once we've done that, we can remove it and we can take it into the installation and use it to prove safe isolation.
So we've now got the complete...
Just one other point as well, where he put the padlock on this external isolating switch, these are quite new. These have only been around for 10, 15 years. You'll probably find the installation where you live in flat house probably hasn't got one of these unless it's a brand new house. So rather than putting the padlock on one of those, if you haven't got one, you'd actually put it on the main isolator in the consumer unit, which is the norm. Okay.
Consumer unit turned off. We genuinely believe the top of the switch is possibly isolated from the remote linked main switch, which we secured, signed and padlocked off, but we've still got to prove that the top of the linked main switch is isolated before we start work in here. We're going to use our approved voltage indicator, which we've checked before using, and we're going to do it in exactly the same sequence as we did when we rechecked supply polarity. However, this time we don't expect any illumination of the instrument at all because the installation should be dead. So as previously stated in one of my presentations, we're going to probe on the appropriate order, the least dangerous conductor first. So I'm going to test between line and neutral first. I'm going to probe onto the neutral conductor first, then the line, then I'm going to remove it from the line and then the neutral. This time we do not expect the instrument to illuminate, so therefore it would be dead. When we recheck supply polarity, we're expecting at this stage to illuminate, but we've isolated the supply, so we're looking for it to be dead, so no illumination of the instrument itself. So if I probe on first of all onto my neutral conductor, and then onto my line, we can see that the lamps are not illuminated, suggesting it's dead. We pull off the line and we pull off the neutral. Next, I'm going to probe onto the neutral and the earth bar. This time I'm going to probe onto the earth bar first and the neutral bar second. So we're going to probe on, first of all, if I can keep my arms out of the way, we're going to probe onto the earth bar and onto the neutral, and we see that it isn't illuminated. We pull off the neutral, we pull off the earth bar. Finally, we're going to test between line and earth bar, once again going on the least dangerous conductor first. In the earth bar and the line, pull off the line and pull off the earth bar. By doing all three stages, we've proved the supply coming into this distribution board or consumer unit has been isolated, yet we're not ready to work on the system just yet. One final check of our approved voltage indicator before we work on it. In case this has become damaged or faulty during the process, we need to prove again that this is in good working order before we come back into the consumer unit itself.
So to prove that my voltage indicator has not become damaged or faulty during the process, I need to put it back into my proving unit and prove it's in good working order. Only after completing this test on the instrument can I suggest that the consumer unit is isolated and safe to work in. So as I probe it in, I expect to see all the lamps illuminate. So it's still in good working order, suggesting that I have proved the safe isolation of the consumer unit, therefore it's now safe to work in that unit.
Having rechecked our proving unit, we're now happy that we can work inside the consumer's unit itself. It's fully isolated from the linked main switch in the tails. That is locked off, the keys are in my pocket, there is a sign present suggesting the supply has been turned off, and we can now go about doing tests, adding an additional circuit to the consumer unit safely. I hope this video has been some help.
Okay. There we go. Okay, hope you found that useful. So, as I reiterate, safe isolation is the most important thing prior to testing. You must always do it. Make sure that circuit is dead. Okay, I hope you made some great notes because I've got 10 questions for you now. The questions are all about the video and the PowerPoint. You'll see the answers come up at the end. You'll get feedback on what you've got right, and you'll see the correct answers in green, and we'll go through some of those. Okay, so identify the appropriate instrument to check that a source of supply has been switched off. That's question number 1. Question number 2. You're about to isolate a circuit in a busy office. You notice that the circuit to be isolated has already had an MCB switched off in the fuse board. What action would you take? Question number 3. What is the guidance for safety reference number for safe electrical isolation? Question number 4. When more than one operative is working on an isolated circuit, what should be used to prevent operation on the main isolator? Remember, this was on the video. Question number 5, halfway through. Where fuses are used, the removal of a fuse is an acceptable means of disconnecting the supply, but only if Question number 6. Identify the function of the proving unit. Question number 7. Identify the part within a GS approved voltage tester that would primarily protect the tester from explosive damage should a short circuit in the tester during use. Question number 8. Where is the most suitable location to isolate a live supply to a circuit in a domestic installation? Penultimate question, number 9. Which one of the following is not a GS38 standard requirement for voltage indicator devices? And the final question, number 10. Which one of the following is not good practice when carrying out safe isolation? Okay, well done. Hopefully you got 10 out of 10. You should have our answers fed back to you right now. Okay, so we'll just skim down and see the correct answers. So you can see which ones you got wrong, if indeed you did get any wrong. Hopefully you got 10 out of 10. GS38, you remember we talked about that earlier when I showed you the finger guards. The internal fuse, which I said rather that blowing up than your very expensive test equipment. There we go. Okay, let's get back to the full screen. So I hope you've learned something on that. And just to emphasize again, safe isolation is the most important thing when it comes to testing. Make sure you're safe. And indeed, everybody else on the installation is safe. Because if you leave something open, somebody could be in another room, another decorator, another painter, another electrician, a householder. Somebody could be touching some live cable where you think it's dead. So always safely isolate before work starts. Okay? So thanks for attending. It was really good to have you with us. There's more sessions coming up, so make sure you keep an eye out on Student World and book the sessions which you think are appropriate for you. So please stay indoors, stay well, stay safe, and see you on the next one.